Okay, so I had already done this problem before. If you look at my submission, and I already uploaded the video about how I solved it. But when I submitted, I did notice that it was taking a while to get the status. It's because my runtime is pretty slow, and it's also taking a lot of memory. So I, went through the discussion, and I also YouTube some videos trying to figure out how I would be able to optimize it more. And it was a bit, I feel like all of them were solving exact same way, but it was just a bit hard for me to grab the concept. So I landed on this video by Andy Gala, and I think he explains it really well in his video. But I am going to, code out the new way or more optimal way anyway, just as a practice for myself. And I think it just helps me understand it better when I just, talk and explain to you guys and, see if I can make you guys understand, I guess. Anyhow, so we're going to be redoing this problem. So the question asks, given an integer array nums, return an array answer such that answer.I is equal to the product of all elements of num, except num at I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. You must write an algorithm that runs O of n time without using the division operation. Okay, so like I explained in the other video, so what they gave us was an array of numbers, and they would want us to return output that's a multiplication of all the element but the element at the certain index. So for this problem, we were given 1, 2, 3, 4. So our first answer is 24, because if you multiply 2, 3, 4, we would get 24. And for our second case, if we multiply 1, 3, 4, it would be 12, and so on. So for us to be able to answer this problem in more optimal way, we would have to generate two array with the same length as nums. So one we would call it a left, and another one we would call it left. So the idea is that, let's say we have an array 1, 2, 3, 4, and then let's do a left. So what we would do is initialize the left with 1. And what we would do is we would multiply 1 times 1. So let's put a multiplication sign if that makes easier. So if we do 1 times 1, we would get 1. And in the second round, what we would do is put another multiplication, let's say, so if we do 2 times 1, we get 2. And for our next answer, we would basically do 3 times 2, which would give us 6. So we would do that until we have same numbers of element as the elements in nums array. So in another case, we would do the same thing with the right. So for the right, it's about the same way, but it'll be like coming from like backward. So let's just copy that again and put it right there. So this one, let's try to align it a little bit better. What we can do is have an array, and this one would start from the back. So we will initialize the last element with 1. So what we would do is, let's put imaginary or x in there. So it will be 1 times 4, then we put 4 right there. Then we would do x right there. So 4 times 3 times 4, it'll be 12. And then let me align it a little bit better. So it will be x here again. So in here, it'll be 2 times 12, that's 24. So at the end, we would, to get our result, we'll just multiply left with right. So what we would do, our result basically would be left. So it'll be 1 times 24, which is 24. And 1 times 12, that would be 12. And then 2 times 4, which would be 8. And 6 times 1, that would be 6. So that is our answer, like it says in our output. Yeah, it matches the output. So that's how you would solve this problem. So it is a bit tricky. It did take me a while to understand it, but it is, very optimal solution, but it would take you a little longer to think about like how it works. So let's try to code this out. So for this one, we basically need 3 separate for loops. So one for this one for this part, and one for this part. So first, what we would do is initialize our left and right array. So what we can do is we can say let left equals to new array, and then we would pass in nums.length and dot fill 0. Okay, so what this is doing is creating an array with 0 value, but with same length as nums.length. So in this case, we have 4 digit, and it will return us 4 element with 0. But since we said that we want to initialize the first element of left with 1, what we would do is we would just say left 0 equals to 1. So in this case, what we have is 1, 0, 0, 0. That's what we would have. So we would do the same thing with the right, but it's going to be slightly different. So it'll be nums.length dot fill 0. So in here we have same array as left for now at the beginning, And for this case, you know how we initialize the last one with 1. So what would we do is do write nums dot length minus 1 equals to 1. So now what we would have is 0, 0, 0, 0, 1. So that's what we are beginning with. So let's start with our left. So what we have to do is turn this into this. So we can do that with the for loop. Let's say for let I equals to 1, I is less than nums dot length, and then I plus plus. So in this case, we're starting with 1 instead of 0, because if you look here, we have already initialized our 0 index with 1 value. So you don't want to overwrite it. So that's why we are starting with the 1. Okay, so hopefully that makes sense for you so far. So what we would do is now we have to find the we have to replace this 0 here with something else, and that something else is 1. So if you think about how we got to that 1 was by multiplying the first 0 index of nums and 0 index of left. So right now our I is at 1, right? But we want I to be 0. So what we would do is do left I minus 1. So let's say if our I is 1, then it would give us 1 minus 1, which is 0. So that's what we wanted, which is that one. So now we'll just put multiply in there. And then the next value we want is nums, this one, nums at 0, right? So the way we would do it is we do I minus 1 again. So it will also be 1 if our index was 1, minus 1 would be 0. So we would do similar to our right loop. So, let I equals, but then for this case we're starting from backward. So we are looking for this value, which is our nums dot length minus 2. Because if you look at the index, it goes from the backward, minus 1. This one would be minus 2. So since we already assigned the end of the left array with 1 earlier, like in here, we have already initialized it, and we're trying to find a value for this one. We don't want to overwrite this one by saying, you know, nums.length minus 1. You are looking for this one, so it would be nums.length minus 2. And then in this case we would have to say bigger than equals to 0, because we're going backward, right? So we would have to decrement the 1 as you go. Okay, so that, and then we'll run minus minus. Yeah, since we're going backward, it will be decrementing the index. Since this one, like I said, will be -1, and this one would be -2, so we're decrementing. But for our left, we're incrementing because we're going, you know, the index is increasing as we go to the right. Okay, so, okay, hope that makes sense to you. So in this case, we would have right I equals So now we need to figure out what we would do to the I, right? So we were, let's say this one, so we want to access the last element of the right. So that would be -1, let's say. But right now our I is -2, right? So it'll be nums -2. So in order to go back to the last element, we would actually have to increment by 1. So it would be this one. And then we would multiply by nums.I plus 1 as well, because if we were to do just I, it would be like, what are you, right there? But then we want this value, not that. So we're just incrementing by +1. Okay. So at the end, we need to get to this result part. So like I said, we get this by multiplying this left by right, each element of the index. So what we do is we can say for let I equals to nums dot length again, and then I is less than, oh, sorry. For this one, we'll initialize at 0, and then we do nums dot length I plus plus. So in this case, what we have to do is, so I was thinking of, creating a result array and pushing it, the value into the result, but it makes more sense for us to overwrite the nums array itself in order to not increment our space complexity. So what we can do is we can just say nums I equals to left I times right I, and then we would just return nums. So let's comment this part out, and let me quickly go over it. Let me quickly scan it to see if I miss anything. It's like dot fill is kind of new to me, so I'm not really sure if it's to fill or fill. So we'll test it out and see if it works, and we'll test out to fill. But that looks about right. Okay, so let's try to run it and see if we see any errors. Okay, so it looked like it worked. Let's try to submit our answer and see if it passes all the test cases. Okay, so yep, it's much faster than obviously the way I solved it before. So now my runtime is like 100 ms. Before it was, 9 times more. But yeah, so hopefully you guys learned something from this. I did learn a lot. So anyhow, thanks. Bye.